yesterday, okay, we did the fundamental theorem with, like, when they have the integral starting at -1 and we're getting these values, right? We had to take that into account when we're going backwards, okay? But sometimes, actually most times, when you're dealing with rates, there's usually like a starting point. Because like a lot of times this stuff is used for like money, population, things like that. Like if you're talking about a population, usually there's like a starting amount. You're not creating a new species, you know? So like there's fish in the pond to start with, or there's like deer in the park. There's one in AB like that one. But there's always like a starting point or like a starting amount of money that you're dealing with. So for this one, starting at -1, I mean, this is kind of ambiguous case. It's not really applied to anything. Whereas like this one could be, where is it? Where do we go? There she is. Okay, this guy. So like if f is a differentiable function such that f of 4 equals 3.462, and then you're given f prime, what's the value of f of 7? So what you need to do is account for this beginning piece. So that's why I always think population. You're never starting from 0 because you're not creating a new species. So it's always like you're going to take an initial amount. So you're going to take whatever you started with. Okay. And then you're going to add, okay, integrating that rate. But again, wherever you took that amount, I mean, a lot of times in real life it's at 0, you know what I mean? Like you just to make it easier. But like maybe you're starting on month 3, like maybe you start in March, starting to collect data. That means that when you evaluate it, you have to start at 4 wherever you started taking data from. Okay, so say this is like month 4, that's when we're starting. And then now we want to integrate to 7 of natural log x squared plus 5 dx. Okay, so that one you would just type in your calculator. So shoot, my calculator disappeared randomly, so that's fun. Where'd it go? Do I have one? I don't know what that is. That kind of scares me a little. Okay, so what you would do for your calculator is you would go 3.462 plus, and then you would hit math, and it's number 9. You know, hit math, then number 9, and then you'll see the integral on your calculator, and then fill in the numbers, fill in the function, and then hit equals, and then you'll get your answer. So you should get 8.7828. Yep. For your answer. So remember, when you're integrating, it's math 9. Derivative was math 8. So integrating math 9. Really quick, just to add this, say if they wanted to find the value of f of t, like any kind of value. So like, say this is like a offshoot one. Okay, find a function f of t to represent the situation. Okay, so the way you would write that is very similar. You would take the 3.462, then you would add, and then you would still start at 4 because that's your initial amount. So then, because I want my variable to be t, okay, when I plug things into my integral, I want t's plugged in because I want my answer to be t's. So whatever this variable is, bless you, whatever this variable is, you're going to put on the upper bound, okay? And what's in the integral has to be a different variable, Okay, so it has to be something different. I usually just do X because I'm used to it, but it just has to be different. Okay, so if you want a function for f of t, think about it when you evaluate the integral, you want t's plugged in, so then your answer is with t's. Okay, so they just have to be different. And that's like a really nitpicky notational thing, but it's just kind of how it is. Okay. That we don't know how to do that. Yeah, you don't know how to. That would only be calculator. Number 2. Okay. Oh, do you know I put this one on here? They gave you the graph of G. Okay. They gave you the graph of G. Okay. This is the graph of G. Is that G prime or G? Do you know what I'm saying? So if I'm integrating, people are going to start trying to find areas under circles and stuff. That's not it. That's not it. Because if you find the area under the curve, I would be having to find the area under G prime. Does that make sense? Right? So it's like, well, what the heck? What am I supposed to do with this? Okay, well, just integrate it. And you're like, okay, that feels dumb. So you get G of X from -5 to 3, right? And then now you're going to plug in G of 3 minus G of -5. Isn't that tricky? Because you're so used to doing areas under stuff. Okay, but because these don't match, the key is this doesn't match that, not area. So then G of 3, you're like, oh, am I going to do area under that? No. G of 3, this is G. Get a point. Do you know what I'm saying? So G of 3 is just straight up 0. G of -5 is what? 1, 2, 3, 4. 0 minus 4. Okay. That was trick A, wasn't it? Not tricky? I thought it was tricky. Okay. All right, so this is what we're going to do. You guys are going to go to town. So you're given 12 graphs. They're really light, easy graphs, right? Not too much to them, okay? But you have to understand like how you can justify some of these things. So you're given F. So what I do, if this is F's, okay, these are all your F's. I'm going to label them all F. Okay. Each graph is continuous on the interval 0 to 4 and differentiable on the interval 0 to 4. Let G equal the integral of F. Oh boy. Okay. For questions that follow, list all the graphs that would make each statement true. Then state what condition or feature is present in the graphs of F. So you have to justify all these talking about F because that's the only graph you're given. Okay. So like for question 1, the graph of G is increasing on 0 to 4. Okay, so you have to think about if G of X is increasing is a derivative word. So you have to think, okay, that's like G prime. You're going to have to look at G prime positive. I don't have G prime, I only have F stuff. So the correct justification is that these graphs are all positive from 0 to 4. So if you look at the graphs, E, now, okay, E, yes, goes to 0. Think about, because this one is like, but it's a 0, you know what I mean? Okay, think about that graph actually. Think about this is still increasing. Do you get what I'm saying? Even though there's a horizontal tangent there. Do you get what I'm saying? So like it's still, the slopes of the tangent lines are still going up. It's just they're kind of leveling out for a second, but this graph is technically always increasing. Okay, there's just like one time that it's a 0, but it's still technically increasing the whole time. Okay, like it's still going up. So E, G is all positive. J is all positive. K is all positive. Okay, so all of these would be increasing if that was a graph of G. Okay, so ready, go. Get after it. Come on. All right, so a lot of you got F and H. That's not the issue. The reason 3 is none, for G to be a constant graph, it doesn't mean like it's constantly increasing. Do you know what I mean? Like it's not. I think a lot of you are thinking like a line, you know? Like like a constant slope. That's what you're thinking of. So constant slope means like it's constantly increasing in a way to think about it. So a constant graph just means it's a horizontal line. So the reason there's none is there's no f of t equals 0 graph. So if you took a derivative of this, you would just get 0, you know. Concave up, a lot of you are getting this, so that was pretty good. 0, that's when f is increasing. Concave down, decreasing. Concave up on the first part of it, concave down on 2 to 4. So that's G and F are right because you're going increasing to decreasing. And then where's F? Increasing, decreasing. No local extrema is a lot of them. So there's no sign change on F. That's what you need for the local extremas, for like the derivative to go from positive to negative. So like the first 4 do, right? Yeah, first 4 do. Negative, positive, positive, negative, negative, positive, positive, negative. But this is all positive, all negative, positive, all negative. This has a sign change. This doesn't. This one does. So, any questions? Does that make sense? We good? Okay. We're not going to do all these, but like this was an old AP test not too long ago. Well, I guess it feels long ago for you guys, but not for me. So this was number 3, so it means it's a no calculator question. We're not going to do all of these. This is the test that no one got 100 on in the whole world. In the whole world. Did you know that? And it's because of part D. Part D is L'Hopital's. The first time they put L'Hopital's on an FRQ was right here. And then they were psycho about their justification. That's fine. It's mean. It's just mean. You know? Okay, so for part A. Okay, we're going to continuous function f. We have line segments, quarter circle. We know that we've got this rando point. That's gross, but whatever. That's the point. Okay, if blah, blah, blah equals 7, find the value of -6 to -2. Show the work for your answer. So this one is like, where is it? We did one. It wasn't as, that was that 3, where is it? This guy. It was like, that's like this thing. Kinda, in a way. Because they give you some random integrals, but it's not the right interval that you need. So it's like, for crying out loud, you know. So you have to somehow like figure this out and how to break this up. Okay. So we want this. So -6 to -2 f of x dx. Okay, so we're given -6 to 5. So it's like, what? So, okay, this is kind of like how I like organize my life with these. I do, because I'm like super visual learner type person. So like for this one, I know from -6, I do this like little segment thing, to 5 is 7. Okay, so it's kind of janky, but I need to see it to be like, okay, this huge interval equals 7 from -6 to 5, but I only want -6 to -2. Do you see what I'm saying? Like this is like my mystery guy. And then this is where you pray that you can figure out -2 to 5. Do you know what I'm saying? To hopefully like do stuff with it. So either way, I'm for sure going to have to I'm going to have it broken up into -6 to 5 f of x dx, that's from the thing. And then I'm going to subtract that negative 2 to 5 thing. Right? Wouldn't this, I would have to get this answer to get x. So I'm going to have to subtract the integral from negative 2 to 5 f of x dx. And then this is where you pray that, oh, look, how perf. Look at the graph. Negative 2 to 5. What a gem. Okay? So you can like already, do your math for this one. So like for this red one, I'm going to change this to a 7 because it makes me feel better because that's what it was. And then minus, and then I'm going to find the area under the curve. Okay. For your sanity, try to do the little tricks because like obviously like above the curve's positive, below the curve's negative, like you guys already know that stuff. Like don't do a bunch of triangle work if you don't have to. Like all those cancel out. Do you know what I'm saying? So like you could, but it's like annoying because then you have to like do more work with it. Whereas now you can just kind of find the area of this guy, which is just 2. You see it? If you look at the boxes, here's 1, here's 2, right? So there's 2. Well, I guess I should call that a 1. So it'd be 2 plus whatever that circle-y thing I'm going to have to figure out. So 2 plus... Oh, so this is kind of weird because how am I supposed to do that? Well, do you see how we got a square basically? Okay, so I'm going to do the square without this thing. Do you see what I'm saying? To figure that out. So I'm going to go 3 by 3, which is 9. I'm just going to put it in parentheses so I can like organize my life. And then I'm going to subtract the circle or quarter circle. Quarter. So quarter is what? 1/4? 1/4 pi radius squared. What was the radius? 3, right? And then you got to make it look cute, this was no calculator, which is annoying, but whatever. Because this is going to be ugly. That's okay. So 7 minus, okay, what is this, 11? Okay, this isn't that bad. I'm just being dramatic. So this is 11. It's okay, thanks. 11 and then minus 9 pi over 4, right? These negative signs are making me nervous. Okay, so that'd be negative 4 plus. Did I get that? Yeah, I did. Okay, cool. Yay, got something. I think that was worth 2. I think it was 2 points because they gave you a point for this part. I have to double check. I'm pretty positive this was a point and then the answer. So. Okay, part B. Okay. Part B is like the same vibe. Because like you just use your integral rules. So take the 2 out from 3 to 5 f prime of x dx plus integral 3 to 5 of 4 dx. Okay. So, ready, go. I hope this fools you a little. So it's a core memory. Because there's like a good mistake people do on this one. Yep. That's exactly it. Just kidding. Welcome. We've done one like this earlier in the class, so maybe. Tell me how you really feel. It really is ugly though. Yep. It should be pretty ugly. Look at this guy. Oh my gosh. Oh, we're still going. Okay. Wow, it's such a harmony. Did you get it? I don't know. Maybe. Do you remember it?
I swear. No, because me and Olivia couldn't.
Hey, you got it.
It was one of the ones that I got.
But now you did. Or no. Or do you remember?
I don't know. I swear I remember. Maybe it wasn't this exact one, but I remember there being like a circle thing where you had the square and that's.
Maybe. It's not 8. F of 5 is 0. So it'd be 0 minus. No, that's the center. Yeah. Did you get it? Yep. Did you get it? Where is it? Oh, whoa. I don't know what I'm doing. You're throwing me off. F of 5 is 0. Oh, you did the same thing he did. That's where the circle's centered at. The graph is F of 5 is 0. Because you put 3 there. That's supposed to be a 0.
No, but it's F of 3 is 3 minus 0.
Yeah, that's right. You wrote that right. But if you plug in F of 5, you get 0. So it should be 0 minus all that stuff. Yeah. All right. Okay. This was good. Okay. You're not doing area at all under the curve. Okay, so because you're integrating F prime, so you're not doing area at all. So the thing that tripped some of you up, which was cool, so now it's a core memory and you'll never make it again, is if you look at F of 5, okay, you're looking at the graph right here. Okay, this is the center. This is the center of the circle. Center of circle. Center of circle. So you're not going to use that point. Well, you did to know that's a circle, with the radius is 3, but otherwise you didn't need it. So, okay. All right, last but not least, yeah, we'll be good after this, is C. Where do I want to write this? Yeah. C. Function g is given by the function blah, blah, blah. Find the absolute maximum value of g on the interval. Okay. All right. G of x equals negative 2x. Notice the variable change, right? They're doing f of t dt. Okay. So this makes sense that they're calling it g of x versus g of t because when you evaluate the integral, x's are going to go into it, so you want x stuff. Okay, so if you're going to take a deriv, because we're going to do a maximum, okay, so we need to figure out where our locals are and our endpoints, okay, so we're going to have to do a deriv. So I don't know, I'm feeling red right now, so we're just going to do that. If I take the derivative, okay, we did like the hardcore ones the other day. If it was like x squared, you'd have to do chain rule and stuff. It's just straight up x, so it's literally this. This is a full point. This is a full point right here. By saying this is your fundamental theorem, okay? If you want to be extra, you could say by the fundamental theorem. I don't think I haven't seen that where they gave points for that, but you could like be extra, of calculus. Okay. So that's a point, just to be like G prime is f of x. So then what you're going to do is you're going to set that equal, or you could do it all on this line. You know what I mean? You could do it all that way. But you're going to take the derivative and set it equal to 0. And where does that happen? Where does that happen? Anybody? -1 and technically a half. So -1 and a half are your critical values there because that's when the graph equals 0. Okay, what do we need? A max. Okay, is a max going to go at 1/2? No, I mean, so this is what you could do, okay, for this question. You could either explain that, okay? You could either just explain that or just include 1/2 into your chart. I usually do the chart personally. So what I'm going to do is instead of having to explain that that's dumb, it's never going to happen there, I'm just going to throw it in my chart. So we're doing the interval, what is it, -2? Where's my integral? Oh, -2. So -2 is the end. We're going to have to test -1 and a half, even though half is trash. I already know that. And then the upper bound, what is even our upper bound? 5, right? Yeah, 5. Where did I get 5 from? It's in the problem. -2 to 5. So I got to see if those endpoints are the max or not. So now what I'm going to do is I'm going to solve for those values. So remember, G is an integral, so that's kind of annoying, but it's whatever. So G, remember, is -2 to x, f of t dt. So you're going to integrate -2 to 2, which is my favorite, right? Because there's no width. -2 to -1, wasn't that pretty easy? -2 to -1, what is that? A half? So that's a half. Okay, positive half. Ugh, what is that? What would that be? -0.5, right? Yeah, because these two cancel out, and then you've got a negative half area. Or no, not half. What am I talking about? Is that a half? No, it's not. It's a quarter. Jeez Louise. That was being dumb for a second. -1/4. And then 5. Are you kidding me? I got to do 5? Oh, JK. Remember, we did part of it. Remember, we did it? Kinda. Because I need, where was that? This thing. Yeah, it's this thing. -2 to 5, I kind of already did it. Do you see what I'm saying? There she is. Little sneaker. So 11 minus 9 pi over 4. Okay. So as long as you can realize, guys, stop talking, please. As long as you can realize that 5, when you plug 5 in, it's bigger than a half, you're going to be fine, right? So like this is 3.14 divided by 4. So the smallest, think about that as 11 minus, I don't know, 9-ish, kind of. It's actually a little smaller than 9. So the answer is right here. So you would say that, right? We'll do that L'Hopital one a different day because we're going to do, limits are going to come back in full force in this class. So we'll do it then.